All right, guys. So, 17 day 2, solving absolute value inequalities is just like what we've been doing the past 3 days. It's kind of a combination of 1-6 and 17 day 2. So, recall from yesterday or earlier this week, how many solutions are you to seek out when working with absolute value situations? We've talked about how we're always going to be looking for two solutions with absolute value situations. Okay. So, two solutions is the main thing that we learned yesterday. So, examples. Again, we're going to isolate the absolute value and then write two equations. But Ms. Fedorsky, we're talking about inequalities today. Yeah, we are, but we're going to kind of think about the equations first. Then we're going to check intervals. That's huge, the check step. The critical values. We'll talk about that. And then we'll finish the graph based on the results with our interval notation. So hear me out. Absolute value brackets are already isolated here, right? So we're going to write the two situations that are true. We know that x minus 1 would have to equal, again, we're setting it up as equations, 3, or x minus 1 would have to equal negative 3. So we would add 1 here, add 1, we get x. I'm going to throw the inequality sign back in here. So we get x has to be greater than or equal to 4, or x, if I add 1, would have to be greater than or equal to negative 2. Let's graph. I have 0. I have negative 2 and I have 4. I know my circles here would both be closed because they have the or equal to sign. Okay, now watch what happens before we graph. We need to do this check step. Hear me out. You are going to want to pick a point. Okay, I'm going to change my colors here just so you can see this. Over here, in between my 2 points, and to the right of my 2 points. So I'm going to choose for this one to the left of my 2 points, I'm going to choose negative 5. And we're going to plug that back into the equations, the original equation. Okay, so if we have the absolute value, notice how I'm showing my work, of negative 5 minus 1 is greater than or equal to 3. Well, negative 5 minus 1 is negative 6. The absolute value of negative 6 is positive 6. Is 6 greater than or equal to 3? Yes, that works. I'm going to choose 0. It's right here. It is in between, or it's in a number in between negative 2 and 4. So if I plug that in, the absolute value of 0 minus 1 is negative 1. Sorry, and then we would put in is greater than or equal to 3. What's the absolute value of negative 1? Positive 1. Is 1 greater than or equal to 3? No. So I know that this will not work. Over here, we have 4. I'm going to choose 5. So I'm going to plug it back into my original inequality or absolute value inequality. Is 5 minus 1, and then we have greater than or equal to 3. So 5 minus 1 is 4. The absolute value of 4 is 4. Is 4 greater than or equal to 3? Yes. So that must mean my solutions, okay, are over here and on the outside here, okay? What does that mean? This is an OR problem. So now, interval notation. We're going to have from left to right, smallest to highest, parentheses, negative infinity to negative 2, bracket, or remember that or sign is that union sign. It could hit at 4 and go to positive infinity. All right. So same idea as yesterday, but a little bit different in the sense that we have to find those critical points after we isolate the variable. Okay, so let's try number 2 and give us some more space here. Number 2, already isolated, so we know we're going to have 4x equals 20 or 4x equals negative 20. All right, so we could have x, I'm going to bring my sign back in here, is less than or equal to 5, or divide by 4, divide by 4, x would have to be less than or equal to negative 5. I'm going to put these points here, 0, we have negative 5, we have positive 5. All right, my circles I know are going to be shaded, so we could do that much. And now I need to pick my critical points. One to the left of negative 5, all the way to the left, I'm going to do negative 10. I'm going to do 0. That's an easy point in between these 2 points. And I'm going to do positive 10. Okay, so negative 10 for x. We get 4 times negative 10 in absolute value bars, less than or equal to 20. So we have 4 times negative 10 be negative 40. The absolute value of negative 40 is 40. Is 40 less than or equal to 20? No. So that point does not work. 0, let's do that. 4 times 0 is 0. The absolute value of 0 is 0. Is 0 less than or equal to 20? Yes, that works. I'm also going to choose positive 10. The absolute value of 4 times positive 10 is 40. Is 40 less than or equal to 20? No. So that does not work. So that means this must be an AND problem. Anything in between negative 5 and 5 would work as a solution to this absolute value inequality, which means my interval notation with brackets is negative 5, comma 5, bracket. So and problem or problem. You're going to notice the ors always go to the outside, the ands are always overlapping on the inside. I'm going to have you guys do number 3 on your own. In a minute, I'm going to have you pause the video. Remember, this is already isolated. So you're solving as if it was an equation. Okay, you're going to graph it, check your critical points, and then write interval notation for me. Please let me know if you have questions on this. We'll go over it tomorrow. Okay, I'm going to hop on in on number 4. Give us some more room. Yeah, main idea, isolate your isolate your absolute value bars. Can't do it here yet, so we're going to add 3 both sides. Now I'm isolated. I have x plus 2, the absolute value of x plus 2 is less than 10. So I'm going to set this up as 2 equations. We have x plus 2 equals 10, or x plus 2 equals negative 10. Solve, subtract 2, both sides, we get x is equal to negative 8, or x, when I subtract 2, equals negative 12. And instead of those equal signs, I'm going to go ahead and plug the inequality back in. So we have x is less than negative 8, or x is less than negative 12. So here's my 0, my negative 8, negative 12. I'm looking over this. Many of you probably saw this. I accidentally put a negative 8 here. Sorry. And it should be positive 8. There we go. So we have, I'm going to make this an 8, and then eraser, make this a 0. There we go. All right. So now we know these circles, are they opened or closed? Both are going to be opened. All right. I'm not going to draw anything in yet or shade anything because I need to pick my critical points. 0 is always my favorite one. It's easy. So if I check 0, 0 plus 2, 2. The absolute value of 2 is 2. 2 minus 3 is negative 1. Is negative 1 less than 7? Yeah, it is. Still have to check a couple other points. I'm going to choose 10. It's to the right of 8. 10 plus 2 is 12. The absolute value of 12 minus 3, 12, 11, 10, 9 is 9 less than 7. No. Okay, on the test, I want to see that you're showing your work for your critical values. If I were to pick negative 100, negative 100 plus 2, okay, negative 98. The absolute value of negative 98 is going to be 98. 98 minus 3, 98, 97, 96, 95. Is 95 less than 7? No. So that means this is an AND problem. Anything from negative 11.99999 all the way to positive 7.99999 will work, right? It's an AND. So interval notation for this one is going to be parentheses, because it doesn't hit, negative 12 to positive 8 and parentheses. All right. Number 5. So number 5, I moved it down a little bit. We're going to go ahead and, let me see. That's not what I need to do. I'm sorry. Okay. There we go. Subtract 1/3 first, both sides, right? We want to isolate that absolute value bar. So now I have 1/2 x minus 1 is greater than or equal to, I'm going to do common denominator of 12. So 4 times 3 gave me that 12. 3 times 3 is 9. And then we had minus, if I make that 1/3 times that by 4, we get 4/12, right? Common denominator. So now I have 1/2 x minus 1, right? Because that would be isolated, is greater than or equal to 5/12. Or I could have 1/2 x minus 1 is greater than or equal to negative 5/12. So I want to clear the fractions. You could solve this a different way. I just want to get rid of those ugly fractions. So I'm going to super clear it by multiplying both of these by a common denominator, common denominator of 12. When I multiply everything in parentheses in this first one by 12, we're going to get 6x minus 12 is greater than or equal to 5. So those will clear. Or 12 times 1/2 x gives me 6x. 12 times negative 1 minus 12 equals negative 5. All right. From there, I'm going to have you finish solving this one. It's greater than or equal to. Sorry, I'm going to have you finish solving this one. I'm going to have you graph this and do the interval notation on that. And then we'll move forward. All right. Number 1, 2, and 3 down below. So that is 1.7, day 2, part 1. In part 2, I'm going to go and find some better notes because it does not look like these copied. We're going to go over this bottom section. It should not take long. So this is day 2, part 1.